During this math adventure, all we've been looking at are equations, but we can also graph inequalities. So let's think about how we can go and graph those. First of all, remember an inequality simply uses the less than, the greater than, the less than or equal to, or the greater than or equal to sign. So if we are going to take a look at a slope-intercept format using the inequalities, it would look something like this. Y is greater than x minus 6, or y is less than or equal to negative x plus 8. Now, everything else that we've learned about linear equations still applies. So this x represents that slope part, whatever number is before it, and the number represents by y-intercept, so that hasn't changed. The way we work with them is exactly the same too. So if I were to go graph y is greater than x minus 6, well, I know that negative 6 has to be my y-intercept. So I'm reading it exactly the same way as I read it with linear equations. And I can see this is an upward sloping line. And I know that that ratio of rise over run has to be 1 over 1 because there's no number there with my x. So I'm going to go up 1 over 1, place a dot. Up 1 over 1, place a dot. Okay, now here's our first difference between equations and inequalities in the linear form. Okay, remember, sometimes we want the solution as a part of that number that we had, and sometimes we don't. Here, I only want the numbers greater than. I don't want it equal to. So if I just want less than or greater than, but I don't want equal to, I use a dotted line. If I want less than or equal to, or greater than or equal to, I use a solid line. Now it's very similar to when we were graphing them on number lines. Remember, we used an open circle for less than or greater than, and we used a closed circle for less than or equal to, or greater than or equal to. It's the same concept, really. So I see that I don't have an equal to, I just have a greater than. So when I go to do my line, I have to do the dotted line. And you're literally dotting it. Now, lots of kids forget to do this, but you have to do it in order to show no solutions are actually on the line, but they're either bigger or smaller than that line. Now, if we take the second one, I have y is less than or equal to x minus 6. Well, let me go graph it. So I'm going to go to x minus 6. That negative 6 is going to be right here. And I'm going to go up 1 over 1. Okay, so notice it's looking the same, but because I have this equal sign, I have to use a solid line. So that dotted and solid line really are the crucial pieces here in order for us to solve this. Now, we're not done yet, because just like when we did graphing of inequalities, we had an infinite number of solutions, and we always used an open circle and we used arrows to reflect that infinite number of solutions. There's also an infinite number of solutions with inequalities. And the infinite number of solutions can be found either above the line or below the line. And we shade in order to show that. And because we're shading, sometimes we call graphs of linear inequalities half planes, because we're literally going to color in half of that coordinate plane that contains all the solutions that we want. So how do we find out which half to color in? Well, what I do is I pick a point either above or below the line and I plug the point in. And honestly, I always pick the same point. If I can, I pick that origin, because that has a value of 0, 0. And if that works and it is a solution, that means I color that side. If it doesn't work, it means I color the other side. So what I do is I'll take that equation and I'm going to plug 0 in for x and I'm going to plug 0 in for y. And I solve it. Is 0 greater than -6? And if it is yes, it is, then I color that side. If it was no, then I wouldn't. I color the other side of the line. Well, in fact, 0 is greater than -6. So I literally take that plane and I have to shade in the entire thing. And that contains all the answers to that inequality because there are an infinite number of answers to that inequality. So I have my dotted line and I have my shading for that. Now, if I have the solid line, it means solutions are also on that line, but I still have to shade. Now, because this is the same equation, I know that my shading would also be on the same side. So the two added steps with inequalities is you have to remember the dotted or solid line, and you have to remember to plug in a solution to find the shaded side. My favorite solution, always 0, 0. The only time I would not choose 0, 0 is if my line actually went through 0, 0. Then I just choose a point on this side or this side. So that is the only difference with linear inequalities compared to linear equations. You can see that you read them the same way. It's just how you show the answer. Please enjoy today. Get out your art pencils because it's going to take some time to do the shading. Good luck.